Hello everyone, we'll be starting shortly. I'm just going to share a screen with you here. So I just want to see, can you see the file that I shared? It says overview chemistry specification. Thanks very much, Katie. So we'll be starting in a few minutes. So there's a few more people joining us. Can I just confirm, can you hear me okay? Great stuff, thank you. Okay, so just while we're waiting, I stuck a few files up in the chat and the PowerPoint that we're using this evening. And the additional assessment component guidelines, which we'll be referring to later, and the chemistry specification, which again we'll be referring to this evening. And also, just so that you have it, the Bohr's theory was always on the course, but they're making a big deal out of sodium and strontium and they want us to be able to recognize those spectra just by looking at them. So I've got a little Word document there on emission line spectrum that's worth a look. So just while we're waiting for everyone to come in, um, has anyone any questions just before we get started? We'll be starting officially in about 6 minutes. So feel free to jump into the chat box there with a question. Hopefully we'll cover them all this evening when we're talking about the new specification. Okay, so we're just giving people another minute or two to get in and then we'll get started. Good evening. We're just giving people another minute or two to get in and then we'll get started. So I've shared a PowerPoint slide, so hopefully you can see that on the screen. I did try and share some files there, but I think it's because some of us are outside the Institute kind of world. They're not letting me share the files. but it's no big deal. We'll be referring to them anyway, and I've got links on the presentation later, so it's not a big issue. They're all files that are publicly available anyway. Okay, so just one final confirmation then. I'm assuming you can see this message. Okay, so I just typed in there welcome, so I'm assuming you can see that. And the other thing is, I'm assuming you can hear me. Excellent. So we're ready to roll. Okay, so first of all, you're all very welcome. Thanks for coming along this evening, and hopefully I'll be able to clear up any of your questions regarding the new chemistry, and I'm tempted to say syllabus, but we can't say syllabus anymore, specification. So I suppose first of all then, I have slides shared, and I'm just going to get those started, and we'll use those as a template. Now, every so often I'll check back and see if there's any questions, but there's a chance for questions at the end as well. So we'll get this going here. Okay, so what we're looking at this evening are a few key points about the course in general, and then we're talking about the specification, the various different strands, and the cross-cutting themes, and we will talk about each strand in turn. I suppose the big wolf in the room is the project, the chemistry and practice investigation, which is worth 40%. In the guidance that the Department of Education has released, they make a big play on avoiding plagiarism. So we have to reference. And in connection with that, then we'll be talking about the elephant in the room, which is AI. The basic message from the department is if you use AI, you must reference it. And I would be slow to be using AI in the project, apart from maybe brainstorming. But we'll talk about that again later. There's a few useful links that I'll be referring to, and then some general pointers on the course, and then we'll have an opportunity for any questions. So just before we get going then, has anyone any questions at all just before we get started? Feel free to jump in. Okay, so rather than me keeping harassing you about questions, I'll just check back every so often. And if I don't hear anything, we'll keep going until the end. And then, as I said, there's an opportunity to ask questions. Okay, so I suppose the key points initially, it's a 60% written exam. Now, the style of the paper has changed, but luckily for us, the department has released 2 honours and 2 ordinary level sample papers. And they've told us that your exam will follow the structure on the sample papers. Now, my other subject is computer science, so I've been through this before when they introduced computer science in about 2018, and the final papers were reasonably similar to the sample papers, definitely in style. The questions actually were a bit easier on the real exam. For us, we have to do question 1 and any 5 out of 6 other questions. So we have to do 6 questions in total, and the 7 questions on the paper. Question 1, the mandatory question, is drawn from different parts of the course. That's the way it appears on sample paper 1 and sample paper 2. The other questions are more tied to a particular topic. So like there'd be organic, practical, there'd be organic theory, a little bit of thermochemistry, little bit on rates, little bit on kinetic theory. So the questions are more tied to a particular topic, but it definitely varies more than the current chemistry syllabus. With the current chemistry syllabus, you could tie questions to particular topics pretty well. It didn't always work, but pretty well. And then we've got the 40% additional assessment component, which is the chemistry and practice investigation. And we don't need to worry about that yet because it's not released until January. But when they do release it, we have until December 2026 to send it back. Now, I presume when they release the specification in January, they will give us a definite deadline. Well, they'll have to give us a definite deadline for when it's due. The structure is provided in the briefing document. So I'll be referring to these as references to these later in the slides. The structure of the report is given in the briefing document, just like it was in computer science. In fact, the layout of the briefing document, the sample one that they've released, looks very similar to the way they do computer science. So I presume they'll be doing all the subjects much the same way. Okay, so then getting into the meat of this. So I took this diagram from page 11 of the specification, and the specification is available on curriculumonline.ie, and you can also click through it from the ncca.ie website. And finally, I think you can also get it through the examinations.ie website. So there's loads of places where you've got access to the specification. But for us, I suppose the big thing for us, the thing that is a little bit different to the current syllabus, is that they're putting a bigger emphasis on how scientists do their work, how they make observations, put forward hypotheses, design experiments, take results, analyze the results, draw conclusions. And the nature of science is more formal now than it used to be. Now, it was always there, it's just they've formalized it now. The other four strands, the nature of matter, behavior of matter, interactions of matter, and matter in our world, we'll be talking about those. But when you look at the sample papers and you look at the old papers, the questions, while they're a little bit different, they're not that different. So there's a lot of areas in the new specification where you can use practice questions from the old syllabus. So that's a good thing. The more practice we get, the better. So for example, the stoichiometry questions, the mole concept, the questions seem very similar on the sample papers and on the old course as well. And that's true across loads of areas. Looking at the four strands then, you'll notice around the edges there, we've got the cross-cutting themes: technology, sustainability, and health. And if you were a betting person, you'd bet that those cross-cutting themes, some of them at least, will be mentioned in the 40% chemistry and practice brief, which is, as you said, released in January. Okay, so the way they say it in the specification is we should use the cross-cutting themes as a lens to view the content. So the content are the four strands: nature of matter, behavior of matter, matter in our world, and interactions of matter. The cross-cutting themes are ways of applying our knowledge to the real world. Now that sounds very different, but they always did that. On the old syllabus, about 9% of the paper was social and applied aspects. So again, they're just formalizing this thing. Okay, so before we get into the strands here, I just want to get back to the chat just to see if there's any issues or questions or so on. Okay, so you can't see the slides. Okay, so I can deal with that. So Hassani, just to answer your question, the project is from January to December. So January to December. You can see the slides, brilliant. So just checking, is it better if I do it like that, the way it is now, rather than going full screen? I'll keep going the way it is now. Now, that's a good question as well. The whole course is designed, according to the department, to be done in 180 hours. The project is designed to take 20 hours. So that's what, what is it, 1/9 approximately. So about 11%. So 11% of the time should go to the project. But yeah, you're getting 40% of the marks. And I think how they square that circle is that in doing the project, you are revising over the nature of science because you're actually applying your knowledge to the specification. Now, different schools will arrange different options for completing the project, but we're talking about approximately 11%.
Hey guys, my name's David. I work at the Institute. I'm just going to check with Ollie and see what issues he's having. So just bear with us for a second. Thanks.
You can hear me now. Great stuff. So I'll just get off the call. I'll just share my screen again. Okay. Yeah. So can you see that okay? Nature of Science, Strand 1. Great stuff. Back in again. Thanks, David. So hopefully you can see me again. Excellent. Okay. So just looking at the questions, Tasnia, did you hear my answer there? When will we get results of the project? Do we get the results before we sit our Leaving Cert exam? You'll get the results of the project with your Leaving Cert results. I'll just see if there's any other questions there. Hassani, did you hear that okay now? Great stuff. Okay, so I'll get back to my slides now, and I'll just double check. Can you see the slides at the minute? So the way it is now, can you see the slides? Great stuff. So I'll leave it alone. I won't try and go full screen. So we were briefly talking there about the specification overview and how the cross-cutting themes, sustainability, technology, and health act as lenses for the content, and how nature of science is kind of it's kind of encompasses the whole course. It's basically describing how scientists work and how they, you know, put forward a hypothesis, design an experiments, get results, analyze the results, and draw conclusions. And that's basically what you'll be doing in your chemistry and practice investigation, which is what our AAC is called. That's the name they give it to it for us. And there's, across all your subjects, the way things are going, there's going to be 40% AAC. They're slowly bringing that in across different subjects over the years. But here we just care about chemistry. So the first strand then, the nature of science, is, as we said, the spine of the course, and it unifies the other strands. And you're basically trying to develop the principles and practices of working like a scientist. You don't really study the nature of science strand in isolation. You study it when you're studying the content of the other strands, and you develop the skills when you're doing your chemistry and practice investigation. A big push on, and this has always been the case, there's a big push on models to aid understanding. So the example of that, I suppose the famous one, is the plum pudding model, moving to the nuclear model, the enhanced nuclear model, Bohr's theory, and then the orbital model. So as I think a famous statistician once said, all models are useless, but some are more useless than others. So a model is just there to aid understanding. You'll be developing research skills and designing a suitable experiment for your chemistry and practice investigation. Now, when you look at the sample one that they've released in September, you'll see that they mention all these terms: reliability, validity, accuracy, precision, the nature of error, fairness, safety, integrity, and selection of suitable equipment. So that seems to be quite random, but all of those terms are mentioned in the specification itself, in the sample one, and it'll be the same in the real one. The other bit of good news is they give you the headings that you need to use for the report, and that's in the sample assessment component that was released in September, and that's up on the website examinations.ie. Well, as we said, we'll have references and links later. Okay, so that's the first block. So just checking back here just to see, make sure things haven't gone dark here. So has anyone any questions at all? Feel free to jump in. I'm just scrolling back here just to see. And there was a question there earlier, how many classes a week would a school give me to complete it? So that would depend on the school, but as we said, it's 20 out of 180 hours, so it's about 11% of your time for Leaving Cert chemistry. So that's fifth and sixth year. 11% of your time should be going towards your project, but it'll be up to your school to schedule that. Okay, so there's no other questions there, so we'll keep going. Okay, so behavioral matter then, the topics, I suppose there's a big emphasis on chemical bonding. Now, none of this has really changed at all from the old syllabus. So that means that past exam papers for the old syllabus will be useful practice for this as well. There's a bit more emphasis on how electronegativity doesn't always tell you the full story, that there are exceptions. So differences in electronegativity give a good indication of the type of bonding: pure covalent, slightly polar covalent, or ionic, but it's a continuum. There's a little bit more emphasis on that. And then there's molecules. I think BF3 is one example where it appears to be ionic, but it actually exists as molecules. So just to be aware that there are exceptions. Intermolecular forces are much the same as they were, but they rename. But they used to call them van der Waals. Now van der Waals is used as an umbrella term. So you've got London dispersion forces, dipole-dipole forces, hydrogen bonding, and ion dipole forces. VSEPR theory, same as the old course, just for predicting the shape of molecules. The ideal gas equation, which is in the maths tables, that there's a big section on that, and there's an associated experiment. The organic section doesn't seem to have as much detail as the old syllabus, but it's still very important if you look at the sample questions. So big topics there in strand 2, just the nature of hydrocarbons, different models to examine, like alkanes and alkenes and alcohols, say isomers, structural isomerism, and then the weird chemistry of benzene. So there's no real change there. When you look at the specification, you'll notice that the experiments aren't as big a deal as they used to be. There aren't as many as experiments on the course as there were on the old course, and they don't seem to be given as much emphasis. But when you look at the exam, the sample exam questions, the experiments are mentioned. There's definitely going to be questions on experiments. So experiments in this section, which were also on the old course: flame tests, tests for anions, and preparing ethene. And this is just like a taster of organic chemistry. There's also more organic chemistry in the guise of thermochemistry in strand 3, and then even more organic chemistry, different families, aldehydes, esters, and so on, making soap in strand 4. So it's all linked up. I know we're slicing and dicing it here just to try and give you an overview, but these things are all linked up, and they want us to link them up. So just checking back here, we'll just see if there's any other questions. So yeah, London dispersion forces, dipole-dipole, ion dipole, and hydrogen bonding. I suppose they'd be the big ones, and they're all under the heading of van der Waals forces, intermolecular forces. Jackson, that's it, yeah. And sorry. There aren't really any new experiments. Like there are things called um, experimental investigations, which we'll be talking briefly about later. They're more research based. So there's experimental investigations, which we would typically call experiments, and then there's research investigations, which wouldn't have been on the old course. Rachel, that's a good question. It's harder to say now, because they do say on the specification that, say, for example, in the volumetric analysis section, they can ask us experiments that we haven't seen. Now, because they'll give us all the detail on the paper, it doesn't matter if we haven't seen them or not. because we'll have developed the techniques and skills when we study our other titrations. So there's no real number that we can put on the experiments because it's less certain now than it used to be. But we can definitely say that the experiments aren't given as much emphasis as they were on the old course. But obviously, it's chemistry. Experiments are important, but more for developing the skills. Okay, so we'll keep going here and I'll come back. We'll check back in a minute just to see if there's any more questions. I'll just scroll up here just to see, make sure I haven't missed one. Okay, so I think we're okay. So we'll keep moving. Okay, so strand 3, again, you've got topics that were on the old course like thermochemistry, energy profile diagrams, which are connected to kind of exothermic and endothermic reactions and rates. Hess's law, which is connected to thermochemistry. Rates was a massive topic on the old course, and it still seems to be a major topic on the new specification as well. And catalysts and how they affect rates. Good news for us, I suppose, is that equilibrium and KC calculations are still there because they are very method based. If you understand the method, it doesn't really matter which one they give you because they're all done the same way. The acid-base theories, they haven't changed, Arrhenius and Bronsted-Lowry. Now, electrochemistry, there was electrochemistry on the old course. They seem to be pushing the electrochemistry further on the specification. So electrochemistry would be one of the few areas where there's probably more on the new specification than the old syllabus. And then the experiments in this section, heat of neutralization, which was on the old course as well, heat of combustion, factors affecting rate of reaction, like, change in concentration or change in temperature, change in particle size. Equilibrium then, a simple equilibrium experiment and seeing how temperature and concentration affect equilibrium. There's a little bit more emphasis on displacement reactions. They were on the old syllabus as well. So for example, if you put a piece of magnesium in copper sulfate and then take it out, the magnesium will get coated in copper. So that's kind of an example of a displacement reaction. There's a bit more emphasis on that. The galvanic cell was on the old course. The electrolysis of water was on the old course. But there's a bigger link about the use of batteries. You know, we've all heard of um, electric cars powered by need. The chemistry of batteries now is very, very important. And if they could just discover ways of charging the battery faster or making the battery smaller, obviously that would be a major plus in our modern world. Um, the acid-base theories and neutralization that are mentioned in strand 3 also reoccur in strand 4. So they're trying to push this idea that we can't slice and dice these strands, that we have to take them as a whole. But obviously when we're discussing them here, we have to kind of break them up a little bit. So just before we go on to the next one, we'll just double check back here, see if there's any questions. So Jackson, it depends what book you're using, or maybe your teacher might be using notes. On the old syllabus, it was chapter 20, I think, in Chemistry Live, but I couldn't give you an answer on that one, but it definitely is there. That's a good question, Rachel. I've looked at both the Chemistry Live one and the Cracking Chemistry, and they're both very good. Um, it would, I don't have that book at my elbow, Jackson, but it's definitely there. put it like that. Yeah, any of the books I've seen would be worth using. My school stayed with Chemistry Live just because they'd always used it. But to be honest with you, the main thing for you is to look at the specification, look at the old sample papers. The books are only there as a scaffolding. They are the author's interpretation of the specification. It's always better if you have a look at the specification for yourself. Yeah, there's a little, just reading the next question there. There's no real changes in the test for anions, except that they're putting more emphasis on learning the equations now. The equations were always there, but they used to never really ask them. But they seem to put more emphasis on that in the specification. Now, having said that, when you look at the sample papers, they don't seem to go into it in any detail. Regarding the history of the atom, there's a lot less on the new course than the old course. So it has been cut down. No problem. So I'll come back to questions and so on later on, but we'll keep pushing here. But don't be afraid to throw up your questions because it's better for everyone. Okay, so final strand then is a big one. And again, there's a little bit of good news here for us, especially when it's great to have a bank of past questions to analyze. So we've got volumetric analysis. People commonly refer to that as titrations. So you're using one chemical whose concentration you know to find the concentration of another chemical. The only big change with that is they said specifically on the specification that we could be asked problems, experiments that we haven't seen. And that's where understanding the method and the process for answering these questions is important. Because then once you understand the process, it doesn't really matter which one they ask you. It's kind of like stoichiometry questions that way. Um, there's also a good bit on organic compounds, alcohols, aldehydes, carboxylic acids, and so on. Organic tests like the failings test, um, organic mechanisms. The good news for us is there are still only two mechanisms that we need to know: substitution and addition. So that's a little bit of good news. Now, new stuff in this strand, it's always been there, but there's a bit more emphasis on the use of chemicals in the pharmaceutical industry, but it seems fairly generic kind of stuff, you know, verging on common knowledge rather than particularly chemistry rich. There's a little bit on polymers, but polymers were always on the course, things like polythene, polypropylene, and so on. And what's a little bit new is there's a section called chemical environment where they talk about, say, microplastics getting into water, um, why we should move to renewable energy, that sort of stuff. And again, some of that material is verging on general knowledge, but it is there in the specification. You wouldn't be surprised to see some of that maybe coming up in the chemistry and practice investigation. The experiments, they list 5 titrations that we have to know about. So this is one of the few sections where they were fairly specific on the experiments that we have to do. There's organic tests like the one I mentioned, the failing solution one, making an ester, making soap, and making benzoic acid. all of those experiments were on the course. Okay, making an ester wasn't really emphasized too much. It's emphasized a bit more on the new specification, but it was there. It was kind of on the edge of the old course. Um, there's an opportunity to practice research in the research investigations, and you'll know those because when you look at the specification, instead of EI, which is experiment investigation, you'll see RI, which is research investigation. So there's an opportunity to practice your research by looking at an area of the course through one of the cross-cutting themes that we mentioned earlier. And we'll be talking about those cross-cutting themes again in a second. Do you remember we said health, sustainability, and technology? And they're actually that vague about it. When you look at the specification, they literally say you can just pick an area of the course and practice your research. So just checking back here. Yeah, if I had to pick a section that they've added onto in a major way, it would only be that last section that we are talking about. You know, the microplastics in water, the pharmaceutical industry, how we need to move from, fossil fuels to renewable energy, the kind of more general part of the course. That's where things have been added on. They've changed the kind of emphasis on other areas. So, for example, the history of the periodic table used to be a big deal, Dobereiner, Newlands, Mendeleev, and Moseley. But now we focus totally on Mendeleev. So like things have been changed, but not changed by that much. And you'll see that especially when you look at the specification itself. And so that's a good question. The unifying strand is important because that's kind of like your skills that you're developing. The idea that, like some of it is fairly obvious, to be honest with you. Like if you were doing a titration experiment, you wouldn't just do it once because that wouldn't give you a very trustworthy result. You might do it 2 or 3 times. And if you get um, similar results, your results are reliable. Now, that's no big deal. People are familiar with that, but that's kind of what the unifying strand is talking about. The point I was making earlier, you don't study the unifying strand in isolation. You study it when you're doing just experiments from the other strands. So you'll cover it that way. I think in the Chemistry Live textbook, there is a chapter on the unifying strand, and I'm sure there's one there in the cracking chemistry one as well. All of these books were written off the same specification, but the big thing for us is we need to not look at someone else's interpretation as well as their interpretation. We need to look at the specification ourselves. That's the main document for us. And then, Rachel, bad news, unfortunately, if you read the specification, they do say that we have to know the equations, but they said that for the old course as well. And they used to never come up, or very rarely, very simple versions of the equations. Like there's two bad ones there, the brown ring test for nitrates and the test for phosphate. Learning those equations wouldn't be easy. And to be honest with you, it would be way down my list of priorities. Okay, so I'll come back to you again in a couple of minutes, no problem. Thanks for asking the question, Rachel. Um, so we'll go back to our little PowerPoint again. So now I had mentioned cross-cutting themes, and their health, sustainability, and technology. And as I said earlier, you use these themes to explore the application of knowledge gained from the four strands. Okay, so that's where that's coming from, and also the unifying strand. And just I mentioned this earlier, throughout the specification, you'll see little mini projects labeled RI. So EI for experimental investigation, what we commonly would just call an experiment, and then RI for research investigation, which is just an opportunity to practice for the additional assessment component, which for us, they call it the chemistry and practice investigation. Okay, so just before we get stuck into the additional assessment component, we'll just double check and just see if there's any other little questions here. We're all right so far. Okay, so officially we've been told that the chemistry and practice investigation brief will be released in January 2026. And we've a little bit of good news. The structure is similar to the sample released in September 2025. So if you go on to the examinations.ie website, and I think if you scroll down the front page, you will see a link for revised specifications. And if you follow that link, it will give you the sample papers and the sample chemistry and practice investigation. And the structure of it is going to be exactly the same as the one we will get in January. So it'd be worth having a read of it. I'm not saying you'd have to do it. You've plenty. I'd concentrate on the theory. But if you have a read of it, this is what I printed out earlier from that website. But if you have a read of it, you'll notice that just like the computer science project that they do, they actually give you a template for the headings that you have to use. They actually give you a page where it tells you how the marks are going to be allocated. So there's an awful lot of information in the brief itself. And just to get a head start, I definitely would read the sample one that was released in September 2025. So you're going to do research related to the brief, an experiment related to the brief. And this is a big one. You must gather primary data. So you must do an experiment that you can get readings from. You'll then analyze the data, hopefully get a couple of graphs out of it, maybe 2 graphs, and draw conclusions. And the structure to be followed, they're not just giving us a blank page and telling us away we go. They're giving us a structure to follow, and they have to, because when these are marked, they have to be marked according to a marking scheme. If students don't follow the structure that was given, it'd be impossible to mark them, or at least very difficult to mark them. The outline marking scheme is given on the brief. On the back page of the sample brief, you'll see it there in examinations.ie. So if there's any questions there, get them into the chat box, but this is just a related slide. I got this diagram from guidelines to support the chemistry and practice investigation. Now these guidelines are designed for teachers, but they're available to everyone. So there'd be no harm for you to have a look through them. You know, they're publicly published, so there's no reason why you can't have a look at them. So what they want us to do is read the topic, initial response, that's like brainstorming, do background research, design and plan the experiment. And you have to be realistic. You know, a school lab isn't going to have the same equipment that maybe a university lab would have. So you have to be realistic with your design and plan, but there's nothing to stop you mentioning that if money wasn't an issue, you would have done this. You would have used a mass spectrometer, or you would have used some other bit of equipment. You conduct your experiment and you take readings, and you make sure your readings are valid, reliable and accurate. And then you analyze the data, probably, as I said, doing a few tables, do a few graphs, and form conclusions. And they mention this in the specification, in the briefing document that you will get. Do you see these words: reflection, review and refine, communication? These are terms that you will get marks for, but you don't have a separate section for those terms. You're supposed to show that you've reflected, that you've reviewed and maybe refined your experimental method, and you communicate it to the person reading the final report. You use suitable language and you communicate your ideas clearly. That there's marks going for all of that. And then you finalize your report, you save it as a PDF, and you give it to your teacher, and your teacher submits it on the portal. So all of that information is available on guidelines to support the chemistry and practice investigation. It's a Department of Education document. Okay, so just before we get on to referencing, I'll just see if there's any other questions here. So anyone want to jump in, feel free. And thanks for your attention so far. Okay, so it looks like we've no questions there, so we'll keep going. Okay, so in the specification and the briefing document and in the guidelines for teachers, they make a really big deal about referencing to avoid plagiarism. So we all know, like, plagiarism is passing off others' work as your own. So we have to reference, and this includes any use of AI. So in order that your teacher can sign off that the work that you're presenting is yours, they have to monitor what you're doing over the course of the number of weeks when you're doing the experiment. So what I'd advise you to do is keep a log of your activity. Now that log could be a little notepad, or it could be a Word document that you keep adding to. But just to make writing the report easier at the end, I would keep a reasonably detailed kind of log, I suppose, document of what you did and why, and most importantly, the sources, the references. So suppose we wanted to do a sample reference, and to give them their due, they actually tell us how to reference. So the reference, the detail of how to reference is given in that guidelines for completion of the chemistry and practice investigation. So suppose we said kerosene is used as an aviation fuel, and we got that information from page 34 of a book by Kennedy published in 2018. So that's the in-text citation. That's in the body of our report. And then in our reference list, we have Kennedy T, Tony Kennedy maybe, published in 2018, and in italics, the name of the book was Fun with Aviation Fuel. Now, obviously, all of that's just made up, but that's how we do our references. And they also give examples of referencing a newspaper, a website, even ChatGPT. They give examples of all of that in the guideline document. So that's well worth having a look at. So before we get on to the elephant in the room, we better just see if there's any questions here. We're all right. Everyone's still okay there? So I'm going to do a smiley face here. Anyone doing a smiley face? I just want to see who's playing Call of Duty at the minute. I think there might be a few Call of Duty people. It's just terrible not to trust people. Anyway, we'll keep going. Right. So, um, as I said, the elephant in the room, and they're really big about this in the guidelines and in the specification brief that you'll get in January itself. If you use AI, you must reference it. You have to. You can't pass it off as your own. You'll know yourself a lot of the time. You can tell whether AI has been used just by the style of English in it, how it doesn't match with other English in the report. So it can be fairly obvious. Now, knowing something and proving it are two different things, I know, but I wouldn't take the chance because there's some very serious um, consequences if you get caught trying to pass off other people's work as your own, and that includes AI. So the links then, you can see there the first one there, the chemistry specification is curriculumonline.ie, and the senior cycle, the state exams commission, that's examinations.ie. You'll find it there. And then that other document that I was talking about, the guidelines, is curriculum online, i.e. so the first one, the specification and the guidelines, are on curriculumonline.ie, and the other one, the access to the sample brief and the sample papers, 2 honours, 2 pass, they're from the State Exams Commission, so they're available there. So just one quick check before we deal with some pointers here. Exactly, Tasnia, exactly. You have to reference where you got it. That's an interesting one. Sorry, I haven't got your name there. I can only see AH, but fair play to you. You've asked some good questions this evening. Um, I would like the textbook, it's there for a reason, the chemistry textbooks. I would use them certainly, but I wouldn't be put off using websites. There's, if you Google it, there's a kind of a structure for judging the quality of a source called prompt. So if you Google that, there's loads of different kind of frameworks that you can use to judge the quality of a source. So if you were given like a source from a newspaper like The Guardian or The Times or something, probably you'd trust that more than if you're no harm to them. My brother used to work for them. If you were given a source for The Sun, okay, you might trust The Guardian or The Times or the Irish Independent, whatever, more. But that's where that framework prompt would come in to help you judge your sources. But you don't have to put any of that in your report. Um, but there's no problem using a book or website as references as long as they're trustworthy. And that's where prompt would come in to judge the quality of the sources. So that's a good one, Anish. What I would personally do is I would look at that sample brief and I would read it from cover to cover and just continue doing the theory, because without doing, you won't be able to respond to the brief unless you've got some theory done. And also you might find that when the brief comes out, I know I might have to do this with my class, you might find that you have to change course. So you mightn't have done much organic chemistry, but the AAC might push organic chemistry. So then you'd have to get the organic chemistry done. So things might have to change in January for you, but we won't know until the brief comes out. But for the minute, the best thing you can do is look at the sample brief, make sure you're kind of familiar with that, and just research the terms that they mention, like fairness, accuracy, um, make it reliability, that sort of thing. But the main thing is carry on with the theory. Is that okay, Anish? Okay, so I'll just go back. There's a couple of little points here that I'd like to mention before we quit, and then we'll leave plenty of time for questions. Okay, so just what I've noticed by reading and rereading the specification, but also kind of teaching some of this stuff in class so far. Um, on the old exam paper, they used to always put constants and molar masses on the front of the exam paper. Now they don't do that. So they expect us to get the maths tables and get all our numbers, all our constants, all our formulas from the maths tables. Now we would have always got formulas from the maths tables, but it's a little bit different. Just connected with that, in the good old days, we would have so in the good old days, we would have maybe found the molar mass of water. Now, I'm not going to use subscripts or anything here. So, bog standard H2O, and we would have went twice 1 plus 16 is 18. And that's the way we would have done it. But now they want us to use the molar masses to 4 significant figures. So I think oxygen is something like 16.00, something like that. And hydrogen is maybe 1.008, something like that. So we just need to be aware of that now. So, and we always round our answers to 4 significant figures unless they tell us differently. If you look at sample papers, and sorry, just to go back to a question that was asked earlier, what do you do between now and when the spec comes out in January? You continue doing the theory, but when you're doing the theory, I'd keep referring back to the sample papers. And you'll notice that definitions are still important. On the old course, they made up about 24% of the average exam paper. It's hard to tell from just 2 sample papers, but definitely definitions are still there. They're still asking ionization energy, still asking electronegativity. So those definitions are still there. Volumetric analysis is a key area. People commonly call that, as we said earlier, titrations, but you can be asked about experiments that you haven't seen. That's new. But if you can do one titration, you can pretty much do them all because it's the same equipment, same methods, pretty much. Um, Organic chemistry, while it mightn't have as much detail in it as it used to, it's still a key area. And if you look at the sample papers, you can see theory questions, experiment questions, and also thermochemical calculations, just like on the old course. Okay, so throwing it up then just to see if there's any questions. So feel free to jump in, any questions at all. Well, Rachel, you'd know, I suppose, from the results that you're getting in class tests. Um, some schools now would have winter exams, definitely Christmas exams may be coming up. So you'd know from that. Going over any subject through it is kind of back to their lenses that they talk about in our specification. Going over the course with someone looking at it from a different angle can help. The more times you go through this stuff, the better, to be honest with you. But I appreciate time, and obviously money is an issue. Um, Asini, that's an awkward one because a teacher has to sign off that you're doing the experiment. Sorry, the project, the chemistry and practice investigation. So that is not straightforward. So you'd have to talk to people about that. So prompt, if you Google prompt and Open University, Open University use prompt to judge sources. When you're Googling prompt on its own, yeah, it's probably, the way that when you're using AI, you get better results if your prompt is good. It's probably getting confused with that. But prompt is a framework used to judge sources. I'm sorry for referring to you as AH, but hopefully you got that one. And then Rachel, um, yeah, if assuming you're using a textbook, what I would do is, first of all, I do the questions at the end of the chapter. That's obvious enough. And then I would look at the summaries at the end of the chapter. And then finally, the pictures of the experiments, and then learn any definitions. Now, I know that's not reinventing the wheel, but that is effective. And chemistry, like most subjects, responds to, being active. So doing questions, looking at the sample papers, that would definitely pay dividends. I hope that's okay, Rachel. Shauna, oh no, it's totally corrected by the State Exam Commission. The teachers have nothing to do with it. They're supposed to monitor, well, they will monitor students when they're doing their project, and they're not allowed to kind of correct them or give help, but they're allowed to maybe suggest resources and so on. So they can't help directly, but they can help around the edges. But totally corrected by the State Exams Commission, just like the exam itself. Nothing like CBAs. Um, Isla, I'm sorry if I'm not saying your name right. You see the project brief, the sample one. So I'm just reading your message there. So are you talking about the sample project brief? So if you look at that one, they're from memory, I think they're talking about acid and carbonic acid. So you could investigate maybe the amount of acid in different fizzy drinks, maybe at different temperatures. So the main thing to do, I suppose, is have a look at the brief itself and then see what variable you're going to change and what variable is going to change as a result, and then try and keep the other ones constant. So like say, and I'm definitely not telling you to do this, it's just off the top of my head. Say you were investigating, does the amount of acid change across fizzy drinks? You might keep the volume constant. You might use the same pH meter, whatever. Um, you might then measure the variable that you're investigating. So in a way, it's not that different to a CBA, but you have to relate it to the brief. And yeah, like I remember this with computer science, my other subject, you have to hit them over the head with it. You have to really make it clear that your experiment is related to the brief. I hope that helps, Isla. No problem. Has anyone any other questions there? Feel free to jump in. Okay, so I don't want to be, I know you're busy people and you're young, you still have life to live. So I won't rob any more of your time. Thanks very much for turning up this evening. And just Rachel, I see that uh, you'd still give it in, like say you're given an answer in scientific notation and it was like 1.2345 by 10 to the minus 4 or something. If we look at that, that's got 1, 2, 3, 4, 5 significant figures. So you'd round that to 1.235 by 10 to the minus 4. So you keep it in 4 significant figures all the time. And Sarah, yeah, that's interesting now because in computer science, there's the same debate. Talking to people, and having marked the project in computer science, um, it is better to show that you have stuck to the brief. You could do a brilliant project, and if you don't stick to the brief, you won't do as well as if you did a reasonable project that stuck to the brief. So as I was saying, I think to Isla earlier on, you have to really hit them over the head with how you are sticking to the brief. No problem. So listen, thanks very much for turning up this evening. I hope you got something out of it and best of luck in your chemistry studies. And hopefully I'll see you at some stage in one of the institute classes.